Continuing our discussion on format string vulnerabilities, we've finally gotten to the fun part. We figured out what format string will give us the appropriate value for EAX, the location of the memory that we're going to write to, and what value for the format string is required to have ECX loaded with the appropriate value, that is the address of our shellcode. We said that %n would count the number of characters printed out, and we used a couple of format length specifiers in order to achieve that. So here is a very simple Python script. We start out here, we import a few modules, the subprocess module in particular, and then here is my shellcode. I allocated 24 bytes for shellcode. Turns out that I only needed 16 to run this particular shellcode. So what I did is I padded it at the beginning with hex 90 values. And you might recall from earlier videos that this is a inop, no operation. It doesn't do anything. So this is what we call a nop sled, sometimes a nop slide, that is used so that if you have an exploit and you're not exactly sure where you might land, if you're off just a little bit, you can put a bunch of nops at the beginning of your shellcode to ensure that it works most of the time. So here I have 8 nops, and then here are my 16 bytes of shellcode, which again, I downloaded from Shellstorm. This particular shellcode is supposed to open the calculator on Windows, and we'll see if it works or not. So I build a string. I start with my shellcode, and to that, I add a bunch of %x's, a couple other characters, and then I add some more %x's, but with format length specifiers. At the very end of that line, I add %n. And remember that %n will take how many bytes have been written so far, and it will store that in the memory address that follows. We said that our address of 0022FE3C was the desired address. And that address was a return address from one of the function calls in our program here. Because you have a 00 in the leading position, normally this might be a problem with things like heap buffer overflows, stack buffer overflows. But in our case, we can actually use the null terminating character to our advantage. So in memory, when this is run, there will be a 0, then 22, then FE, then 3C. And that's how the address will be read, because again, it's little ending. Remember that all of those length specifiers were to get our target length 22FE50, which was the location of this shellcode in memory. So now that we've done the setup, we use subprocess call, which expects a list. The first thing in the list is the thing that you're going to run. Then the next thing would be any parameters. In this case, I only have one parameter. It's the string that we've built earlier in this script. Well, let's see how we do. Let's pull up a command prompt here. Let's go ahead and run Python. And we'll run our exploit script. And if we're successful, the calculator should appear. Notice also we saw a bunch of gibberish on the screen, but I was able to successfully execute my shellcode. Of course, this is a fairly benign shellcode. I could have downloaded something a little bit more sinister, or maybe even launched Meterpreter. We'll talk about all those possibilities in later videos.